Hi class, I want to walk through how you can create an optimization model for manufacturing, essentially from scratch. We've worked a little bit with optimization models for purchasing or supply chain, and so I want to show you one for production here. So I'm going to pretend we're this clothing company, okay? And I'm going to put in product, like a product. We're going to do pants, shirts, and hats, okay? And I need to come up with some variables or some costs because we're going to produce something. So instead of it being a price and shipping that you might be comfortable with or familiar with for supply chain or purchasing, we're going to do cost in terms of resources. So we have time for a unit of each produced, amount of leather for each unit. We're going to have cotton each, but we also want to do profitability. We don't want to maximize production. We want to have the most profitable items. So in other words, we also have some other things here. So we have price each, we have cost each, profit each, okay? And now over here, we're going to put in some totals because our solver is going to use these. So total, leather, total cotton, how many made, how much time it took, total time. But you know what? Let's just move it over here. Total time here, and we'll put, whoops, my computer is a little, and then amount made, and then we'll put total profit. We'll do made over here and total profit. We'll try to keep them in this line as much as possible here. So for this model, I'm just going to go up to home. I'm going to wrap text so we can see it all there. And I'm going to put in some information here. I'm making this up as I go. 10 minutes for pants, 5 for shorts, and 40 for hats. How much leather? 002. Cotton each, we'll do 1, 2, 3. Price each, we'll do 20. We'll do 10, and we'll do 50. Right now, I'm not concerned with data inc, but just know that data inc is important. I'm just going to get the data out, so to speak. So 12, 5, and we'll do $15 there for cost. Now, profit each is a subtraction of price each minus cost each. Boom, boom, boom. So we will now do the data inc here, whole numbers, so that'll be fine. Total leather, now this is going to be a multiplication problem. So total is the made times the amount of leather used. I can drag that down. Cotton equals the total made times the cotton for each unit. So we can drag that down. Total time equals the made times the time each. And they're all zeros right now because we haven't made anything. Total profit will be the made times the profit each. And this one will be dollar currency. So this one here, I'm just going to highlight it in like a greenish color. That is where Solver can play around and make some decisions. But before we do that, we have to add some constraints. For example, these are the costs, but we didn't tell it how much time, leather, or cotton we have in supply. So we're going to do leather supply. Actually, we'll do it in order. Time supply, leather supply, and we will do hours supply. Okay, so we got all that over here. We'll bump that out. So we have 50 of each, but we have 400 hours available to us. Now we need an objective function or objective cell, so we're going to put total time and total profit. And these are the things that Solver is going to replace. So this is our objective. Total time, this is going to be the sum of all the total time over here. Okay. Now we're going to do the same thing over here for total leather, total cotton, and total profit. Total profit will be the sum of these. And this is actually what we're going to solve for. So I'm going to put in like a little different color there. Total leather equals the sum of total leather. And total cotton equals the sum of the total cotton for the 3 areas. So now we have our calculations set up. We'll hit save. Okay. So for example, let's play around here. If I were to produce one of these, see how the numbers change? Total time was 10 minutes. Total profit was 8. 1 cotton was used. What if I produce 1 of those, 4 of those, and 10 of those? Now our formula is changing. So again, this is what Solver is going to do, subject to honoring these things. So let's go ahead and program it. So data Solver, we're going to set this one to maximum by changing M3 through F5 or M5. Okay, subject to, okay, total time, I believe less than equal to hours supplied, because it'll break if we force it to be equal. But because maybe there's a pattern here where we can't do exactly 400 hours, but we could do 390 hours or 395, etc. So by doing less than equal to, that prevents us. Certainly we don't want greater than, because then it'll break. So hit add, and then next what we're going to do is total leather has to be less than equal to the leather we have. Total cotton has to be less than equal to the total leather we have, or cotton we have, which I just realized I didn't put that in. We'll just put it there. We'll put cotton supply. Oh, I see what I did there. I meant to put cotton supply here. See, even professors make a mistake. Okay, there we go. We're good. There, we'll go back to the solver here. We're going to change this slightly then. So we got leather speaking to leather. We've got C15 cottons, and this is the one we have to fix, speaking to cotton. Okay, so now we have to ask ourselves, total time, did we do the total time? We did total time, yes we did. We want this to be the simplex method, and we'll see if this works. Okay, so, oh, I accidentally hit B11 up there, so I got to go back and actually hit total profit, hit OK. It's running. Solver found a solution. All constraints and optimality conditions are satisfied. So let's double check. 400 hours of total time was used. However, we need to make sure that these are integers. In other words, the total leather used, you can't really, I mean, this works, but if we wanted to make sure that this was an integer, we would have to force it to be an integer, which means a whole number. We can certainly do that, but because we're under the impression here that if we use part of a unit of leather, we can apply it to another production item. That might not be true if a scrap isn't large enough. So you may want to fix that in your model. However, for all intent and purpose, we have now made a model that works with us. I would argue we shouldn't be able to make a third of a unit or 0.46. So I'm going to go into Solver and show you how to fix that. We're going to go add another requirement. We're going to highlight all of these. And instead of this, we're going to put int for integer. We're going to hit OK, and I'll run Solver again. Solver found a solution. In fact, it found it a lot faster. Here we go. 2 made, 12 made, 8 made. Total time was 400. Total profit was 356. And we used 16 units of leather and 50 units of cotton. Now, if I were to play with this and say, man, you know, actually it's going to take us 15 minutes. Well, I can run Solver again. And look what it did. It said, hey, I'm just going to make 10 of these hats then, if it's going to take that long for the pants. So you can see how your models can change significantly based on your constraints, right? Like I can change this. I can put the price to $30 each with my supplier and actually get it for $10 each. Now I run Solver again. I get a totally different answer. Now it's saying make 40 of these. It's the best bet. So just by dropping that to $10 from $12, my model can change significantly. So this is what an analyst might play around with. They might copy these over and over again and say, hey, scenario, you know, price is this, leather is this, etc. Or they might copy this and paste it as, let's see here, work with me, as an image. Where is that button? Yeah, right here. So now I have an image of my model that I ran. Isn't that cool? Oh, now you have that for your scenario that you ran. So just a couple of cool examples, you know, of how you can do this and come up, you know, obviously data ink this because you know it's a real problem. I hate it when I don't see data ink, stuff like that. I mean, we can bundle this up if we want, clean it up and stuff like that. And because this is a calculation, we might want to even do that. That looks a lot better there. You know, put some data ink around this. That's beautiful, you know, a lot better, a lot crisper, etc. So just a way to look at this stuff. And thanks for watching.